Hello. Hi. Um, so welcome to the this week of lectures on Stack, the abstract data type, and recall that we have over the last 3 weeks looked at different data structures, right? So we looked at the linked list data structure, the doubly linked list data structure. Then we looked at the array. We compared the three of them for their efficiency for different implementation purposes. And one of the most important tools that we repeatedly used was the power of recursion, right? So if you look at all the programs that we have written so far, there was definitely at least one recursive function which was implemented. You will also be, reasonably equipped because of the programming exercises that we've seen so far, which have used recursion, and we'll have definitely about 3 or 4 more interesting programming exercises just after this set of lectures are over. In today's lecture, or in the lectures of this week, we are going to have 3 short lectures, right? Each one approximately 20 to 25 minutes long. The first one will be an overview of the stack data type, its applications, and the um, different kinds of uh, uh, different kinds of purposes the stack data type serves. After that, we will that will be a PowerPoint presentation, and just after that, we will have two 20-minute sessions on very important applications of the stack data type. So this might be little more than 20, between 20 to 25. So let's start off with the description of the stack data type and an understanding of what kind of methods are there in the stack data type, and what are the different data items, and also an understanding of the different problems which use the stack data structure in a very fundamental way. So let's just go to the slides. All right, so this is lecture number 9. Actually, it's lecture number 9, 10, and 11. Actually, it's lecture numbers 9, 10, and 11, because we'll most likely not come back to the PowerPoint slides. We'll just go directly to the different programs that we have written associated with the stack data type. Right. You will see, and I'm sure those of you who have already programmed will know that the stack is a very, very simple data type, and it's very useful for many purposes. As we reach the tail of this lecture, we will list down lots of applications of the stack data type. So if you look at the stack abstract data type, you have the following data items. You have ordered set of items of a single data type, and there is also one data item which corresponds for the what is called the bottom of the stack marker. Right? So the value of this variable will tell you whether the stack is empty or not, and then we have the position of the topmost data item which can be accessed in query. The methods that we have, the methods that we have are functions which take in a value and the name of a stack and push the data item onto the stack. We will see what push actually does. And then there are methods. There is a method called the pop method which removes a single element from the topmost position of the stack. And top also allows you to look at the topmost element without removing it. Then we have the standard membership queries, which are the is empty function which returns a boolean value. We also have a function which returns the size of the stack. So before we go to the a set of applications, let us now go to an implementation of these methods, right? Just for you to understand what is the return value and what are the arguments to each of these methods. So for this, let us go to the set of programs that I've written. Alright, so here are the functions. Stack.h, as usual, is a definition of the data type, one node of a stack. The stack interface.h is a function that will be used by the stack interface.h is a header file which will be used by programmers who want to use this stack implementation. There are two .c files you will see. One is called the stack list.c and the other is called the stack array.c. These are the array and the list implementations of a stack. That is, the stack is implemented by storing the elements in a list, and then we have implemented all the methods that was listed in the slides. Similarly here, the stack is implemented. The elements of the stack are arranged inside an array and the methods are implemented assuming that the stack is actually arranged in an array. It is possible to write a single function, but it's better to actually break it down and write it in this particular fashion. Alright, so let us just look quickly at this piece of code, and that will essentially form this particular lecture module. Alright. So the stack.h is very simple. We are creating a new data type. The type name is stack. The type is actually struct stack. Okay? And observe that there is one variable called top, which keeps track of the index of the topmost element of the stack. There is an element called capacity, which keeps track of the total number of elements that could be stored in the stack. Okay? So this is a bit technically incorrect. Keeps the number of elements that could be stored in the stack. That is the size of the stack. Otherwise, the size of the stack. The third data item is the stack itself. Observe that this is stored. This stack actually stores an array of integers, right? And the size of the array of integers will be given by the capacity. So we will see how to initialize the stack and how to say how large the size of the stack is and so on and so forth, right? By looking at the function implementations. Now let's look at the stack interface, which is what programmers use. Alright. So first of all, there is a function called create stack, which takes an argument capacity and returns a pointer to stack. The other two functions are is empty and is full. Both of them return Boolean values. Okay? And the last one is the last two methods are methods to update the stack, right? Which is just to push a value onto a stack, which is pointed to by the variable s. And this one is to push, is to pop a value from the stack. Right? What is to pop a value from the stack? You take an element from the top of the stack. And here is a peek function which takes a pointer to the stack and looks at the top element. In other words, it is different from pop. Pop returns the top. Pop looks at the top element of the stack and removes it from the stack, whereas peek only just looks at it and does not remove it from the stack. So these are the interface files that we will repeatedly use. So let us go to the implementation files so that you have a clear understanding of sorry. All right. So let us just look at the first function, which is create stack. It takes as an argument the integer capacity. Okay? And you can see that the new stack is created here using the mloc function. And the topmost element of the stack is set as -1. When it is set as -1, it's assumed that this is a convention or an indicator that the stack is empty. And the value of the stack, value of the capacity of the stack is kept as the argument. The capacity is stored in the variable called capacity associated with the stack. And And this one, okay, ensures that the stack, this one ensures that we create an array of a certain size and let it point to the stack. So there is something very interesting going on here, right? So first of all, we create the stack object. It is called S, right? And then we initialize the top of the stack value to -1, indicating that the stack is set to empty. We say that the capacity of the stack is the given value capacity. And the last one, we make the S point, the array field, point to an array of integers. How many integers? Capacity number of integers. Okay. So this is, so here we created an array with the required capacity. Okay. And now we return a pointer to the stack S. Right. So therefore we have created one stack here by this procedure. Now let's look at the simple functions, right? So when would the stack be full? Right? So the stack would be full if the index of the topmost element, right, is the capacity -1. Right? So let us just see this. Top will essentially store the index of the topmost position in the array. Remember that the array is indexed from 0 to capacity -1. Right? Therefore, if the value of the topmost element is capacity -1, right, then it means that you have to return 1, saying that the stack is full. Otherwise, you return a 0. Right? So observe here that it is a shorthand way, right? And this is very interesting. This is a shorthand way of returning a comparison. So many of you might have seen such expressions written only inside if and while statements, but observe that the result of this comparison can be returned. Right? So what is this comparison? Just to reiterate, it checks if the index of the topmost element is capacity -1. If it is indeed capacity -1, then it means that the stack is full. Right. When would the stack be empty? We have already had this convention that the stack is empty when the topmost element is pointing to -1, has the value -1. Right. So therefore, here is this comparison. You check if the topmost element, is equal to -1 in the return expression. So these are the decision functions associated with a stack, and here is the stack constructor function, right, or the creator function. Now let's look at how to push a value onto the stack. All right. So when should you push? So let's just look at the logic, right? So the stack object, a pointer to the stack is created, is passed to the push function. It does not return any value, and it also takes as an argument value here. So obviously the first check is to check that the stack is full or not. So the condition is if the stack is not full, right, then you look at s_pointer.array, right, increment the index first and then place the value in the position. Right? So it's very simple, right? So before you put the value inside, you increment it and put the value inside. That is provided the stack is not full, which means at least one location is free. Right? If it is not full, then it means that at least one cell in the stack is free. Right? And you increment the value of the index top first. That is what this says. It says plus plus, which one? S_pointer at top. So before the value is used, the plus plus operator will increment it, and the variable value, the value will be stored inside that particular location. On the other hand, if the stack is full, there is an error message which says that there is a stack overflow, saying that stack is at capacity. Okay. Stack has reached its full capacity and the insert has failed. So when you normally program, you can return a failure signal here. Here also you can actually return an integer value, but just because I'm showing you a simple programming example, I've kept the return value to be return value to be void, and we print out a message. Similarly, let's look at the pop function, which takes in just a stack as an argument, and it checks if the stack is empty, right? If the stack is not empty, then it observe here that you return an element, return the top element first, and then decrement the top element by 1. Right? On the other hand, it is empty. You say the stack and underflow, there are no elements in the stack, and here we keep a constant called int min. It's a sentinel value which is used to signify failure. You can set int min to -1 or whatever you want, just to say that the insertion has failed. Okay, so comes the third function. So observe, push pushes a value onto the top of the stack and increments the top value by 1, right? Pop gives you the topmost value on the stack and then reduces the index by 1. Right? And what does peek do? Peek just checks the topmost element. Right? If the stack is not empty, then it just returns a value of the topmost element but does not eliminate it from the stack. Right? And we'll see why this is very useful, right, in a subsequent lecture. Of course, if the stack is empty, it returns a value. It returns an underflow, saying that the stack is empty and the value it's not possible to read a value from here. So this is the array implementation of the stack. Right? Let's just run through this once. The most important thing is it's a constructor function. This creates a stack, right? And then it populates the stack, right, with these values. Initially, it says that the stack is empty by setting the top value to -1. It says that the stack has a certain capacity, indicating the maximum number of elements that can be stored in the stack. And then you associate an array of capacity number of integer elements, right, to be stored, and you create this array dynamically. Now this creates a stack. Then you have the isFull function and the isEmpty function, which returns Boolean values. Then there is a push function which pushes a value into the given stack as. Pop returns the topmost element and eliminates it from the top of the stack. Peek returns the topmost element and keeps it on the top of the stack. Right? Peek is to like peep into the stack. So this finishes the study of the array implementation of the stack methods. Let's look at the list implementation of the stack methods. Observe that there is a slight difference, right? Here we have a node, right? The node stores a value and also has a pointer to another node, and the name of this type is called a stack. Right? Now, therefore, whenever you want to insert into the stack, you get a new location onto the stack, and whenever you want to delete from the stack, you release a certain element of the stack. That is the planned approach here, as opposed to what we did in an array. Recall that in an array, we actually created the stack object and associated an array with the stack object. Here, the stack is composed of a collection of nodes. Inside each node is one integer element and a pointer to another node of the same type, right? And the type name is called stack. So let's quickly look at the simplest of methods. When is the stack empty? When S is null. Therefore, if S is null, then you just return that yes, the stack is empty. How do you push onto the stack? So what you do is, to push onto the stack, you create a new node, you associate the value into the value field of new node, and if the stack was initially null, then new node becomes the only element in the stack and the next pointer points to null. Otherwise, new node pointer dot next points to S, which assuming that S is the top of the stack. And now you return, now you set S to be pointing to new node. So observe that we have augmented or incremented the size of the stack by 1 unit. Right? So you create a node, you keep the value in the node, right? And then you check if the stack was empty, in which case new node becomes the first element of the stack. Right? Otherwise, you set new node to point to the current first element of the stack, which is S, and finally you say S is equal to new node. Right? Observe that the advantage here is that you have no limitations on the total number of elements that the stack can store. Now let us just look at the pop method from the stack. So the pop will take away the head of the stack, right? So the topmost element of the stack. Right? So for that you check if stack is not empty first. If the stack is not empty, then you say S points to S pointer dot next. But before that, you store the value of S in a temporary variable called temp. Then the value to be returned is called pop value. Okay. Pop value is initialized to some global constant. Right. So pop value gets a value inside the current top of the stack. Now, here is a very important step. What we do is we free temp and return the and then you return the value, which is the pop value. So observe what we have done, right? We make a copy of the topmost element, that is temp of the stack. Right? We check that S is not empty. If S is not empty, then S is made to point to the next element in the stack. Right? Then we take the value from temp value, that is a value to be returned. Now you release temp or free temp, and you return the value that you needed to pop from the top of the stack. Here is the peak function, which is also very simple. If the stack is not empty, then you return the topmost element, the value at the topmost node in the stack. Otherwise, you return a failure symbol which says that reading from the stack has failed. Alright, so that brings to an end the implementation of the methods associated with the stack abstract data type. Right? So before we end this short presentation, let us just look again at the stack files that we have. Right? We saw the stack.h. This was very important for the array implementation of the stack. Right? Then we looked at the list implementation of the stack and the array implementation of the stack, and we also looked at the stack interface file, which is what a programmer will use. And let us just look at the stack interface file. Observe here that the stack interface file is independent of whether you are doing an array implementation or a list implementation of the stack. Right? And this is a very nice thing. Right? So there are two different implementations. One is an array implementation, one is a list implementation. The methods which are implemented in the array implementation or the list implementation, the methods know or use the fact that the underlying data structure containing the stack values is an array or a list, as the case may be. But the interface files, which is what is accessible to a programmer, do not reveal any information about the underlying implementation of the stack methods or the stack access methods. Right? So this is a very important feature in today's lecture. So not only are we learning about the stack data type, but we are also learning about certain very professional programming skills that would be very useful in anyone's career. So we've also compiled, as you can see, two .o files. Let me show the compile commands for you. gcc -c stack list.c. This compilation finishes and the stack list .o has been created. Okay. So similarly, we compile the gcc array.c. Right. So therefore, two modules or two object files have been created. Alright, so that brings to an end today's lecture just on the stack abstract data type. This is a lecture 1 on the stack. When we meet next, we will look at the different applications of the stack data type, and then we will go to different programs. Right? So whenever we discuss a certain application, we will go to a certain program and run that program. So that's the plan. So this brings to an end the first lecture on the stack abstract data type. Thank you.